Hi, folks. One more episode of the Supply Chain Show. Today, I will talk about one of the interesting and one of my favorite topics, which is inventory optimization and modeling. So, what I have today is Nicolas. I know Nicolas personally. I met him once in Bridgestone. He is a consultant. He owns a company called SupChains, and he's also a co-founder of 𝐥𝐤𝐤𝐿, which is a very nice and simple to use forecasting software, which you can go and have a look. Most importantly, the reason I have Nicolas here, because he's written two books. The first one is inventory optimization using modeling and simulation, and the second is the data science for supply chain. So today, the focus of the conversation is around inventory modeling, and most importantly, how to use the Python and the recent techniques like machine learning, and why we as a supply chain people should know that, right? So this is the topic of the conversation. Nicolas, welcome on board. How are you doing?
Great, Muddassir. It's a pleasure to be here with you, talking to you today.
Good. So just tell us anything recent. What are you up to before we get to the questions?
So currently I have the pleasure of preparing a few university classes in Brussels, Amsterdam, and Paris, all of them focusing on forecasting inventory. So it's really great after spending so much time writing the books to spend some time now trying to share ideas with the students. I think it's just the perfect combination.
Absolutely. So let's start with the basic question, right? What is inventory modeling? Why it is important? And what is the benefit?
So I think in a supply chain, what really matters is basically the kind of discussion of action you want to take. And when it really comes down to one of the main action you want to take in supply chain is, should I produce more so I have more inventory? And where should I put this inventory? Should it stay in the factory? Should it be moved to the shop? And if you want to move it to shops or to local warehouses, to which warehouses should you send it to? I think this is one of the core decision, one of the most important decisions in supply chain. So, and it's also a very complex one. So when you do inventory modeling, you try to somehow mathematically try to assess what's your network and where you should put this inventory. And that's basically the science that will tell you, okay, how much inventory do you need and where should you put it?
Right. So, but that's the high level. So maybe you want to give an example just to, for people to picturize the concept.
Yeah, sure. So basically some of the most important thing when you try to assess, okay, how much inventory I need and where do I need it, is basically how volatile is your demand, right? We all understand that if demand is highly volatile, you have difficulty to predict it, you might need more inventory. On the other hand, you also have the supply side. The more unreliable the supply is, the more inventory you need, right? Those are really the core things. What I try to add now, and I developed this idea in the book, and I think it's one of the things that most people overlook and no one is paying attention to, is that you also want to have more inventory for the products that are the most profitable. It makes sense, right? If you sell some very expensive iPhone, you want to have plenty of stock of it because the margin is really high. But if you sell some cheap, not profitable product, I mean, if you miss some, well, it's fine, right? Everyone knows it, but yet if you look at inventory optimization as a science, and if you look at formula online, everyone will be like, okay, let's put the same service level everywhere. I think this is plain wrong. This is one of the things I explain in the book. So I would say you really need to have three pillars in inventory optimization: supply, demand, and profitability.
Right. So how this is different from the classic concept of ABC analysis. So when you do, so when, I have a video on this, and I wrote a blog on this, which we call it ABC analysis using three factors, which is value, volume, and frequency. So when you define your A-class items, you consider your top 80% high value items, your top 80% volume items, top 80% margin items, right? So how it's slightly different, or it's along the same line?
So it depends how you set up the ABC classification. And I guess that today, if you go online, if you go to your website, you will see one way to do the ABC classification. If I would go to another website, you would see another way to do it. I personally, so far, stayed out of any of this ABC classification. Yet I think it can be quite helpful, but it needs to be set up in the proper way. What I'm saying again here is that profitability and margin should be one of the ways to classify items. So basically what you want is the item with a high margin to get a high service level, and those with a low margin to get a low service level. Now, many people that listen to us might be thinking, wow, this sounds really simple and straightforward. Like that sounds like so basic. yes, it is really basic, but that's not what people do. Most of the times they're going to say high volume item going to get high service level, and low volume item going to get low service level. But in practice, you might have some high volume item with a very low margin. And then basically it's not, let's say, profitable for you to keep so much stock of it. Because if you miss some sales from time to time, well, it's fine. The margin is so low.
Okay, now that's good. So margin is so low, you keep the higher margin product in stock more. So when you sell more, you have a high service level and you won't run out. So it makes perfect sense. So now we know why we do it, the benefits at the high level. As you said, it's a concept which is it's established concept, but not many people do it, and you are definitely trying to reiterate the same message to the audience, which is great. So now let's get to the mechanics of how to do it, where to start, right? And maybe you just also explain about your book. So which is the audience demography, who are you trying to talk to on this book, right? And so share about the, let's call it, mechanics and the technical part of the inventory modeling.
Yeah. So to start with, and I want a bit to sell inventory optimization, because I think that inventory optimization, again, which is just the science of trying to say how much you need and why you need it, it's not sexy. Right now, people discuss most of the time forecasting. I also love forecasting and machine learning and those kind of stuff. So inventory, it's a bit like, this is not sexy, it's this thing on the side. I think it's much more important for people to fix inventory than forecast. With forecast, you cannot get, if you improve your forecast really well and you improve it by 10%, the impact of inventory will be minimal. But inventory is where you make money and lose money, right? So now, okay, let's assume that you're convinced inventory is important. What do you need to do? And for who is this book? Doing inventory optimization is not easy. And the point of the book is really to go from the really base, simple stuff, and progress step by step, chapter by chapter, and showing the reader, okay, if you want to do something really simple, this is the way you start. So you get some knowledge and understanding on how it works. And then we're going to add a layer, another layer, and another layer. And each time I'm adding a layer, I'm also saying, well, it's an approximation. It's based on assumption. Pay attention to that, because maybe it does not apply to you. And don't assume that everything will be perfectly working fine, because, well, it just relies on some assumption. But despite the fact that we need to do all these assumptions and it's an approximation, we still understand some very basic model, and we can take some very good decisions that will help people to reduce inventory. One of during the book, in one chapter, I did some research on, okay, but what can we expect from it? Like, okay, but if I do all of this model, will I get minus 1% of inventory, minus 50% of inventory? And you often see consultant and software promoting the idea that if you follow the trick, they're going to reduce inventory by so much. What it seems like is that if you do some kind of good inventory modeling, basically following the advice I give in my book, but you could find some very good advice online as well, of course, you could reduce inventory by 30%. So I want to say to all the people listening to us right now, can you imagine how much cash we are talking about if you can reduce your inventory level by 30%? Inventory by so much money.
Inventory by 30% and whilst achieving the same service level. That's the important part, right?
Yeah. So really, I want people to picture like how much cash are we talking about. So this book will give the tool to anyone who has enough motivation, who is a bit into math, but not so much, and who's just into a bit of data. Like, okay, if you like to look at Excel file, if you like to look at data, at graph, and you think, okay, I have a bit of time, I'm happy to invest into the book or into the time to learn new tools, this is the book for you. But of course, we have to understand that doing inventory optimization is nothing easy. So it's not the kind of thing that you can master in just an hour. You pick up the book and then you go to the field and you say, okay, I know what I need to do now, and I'm going to make so much money. No.
Okay, perfect. So what are the key inputs to start for the inventory modeling? So where you should start?
Yeah. So in those kind of project, and it's exactly the same for forecasting and machine learning and so on, it all starts with something that's not so sexy. It's data gathering. And this is really difficult for inventory optimization, because for inventory optimization, it's really a world where you need to have a lot of data and a lot of different inputs. Many of them being cost. You need to know the holding cost, like how much does it cost to keep some unit in stock. You need to know the transaction cost, how much does it cost to make a transaction to your supplier, but also you need to know your profitability. As I said, I strongly believe that currently people do not look at profitability when they do inventory optimization. you need to know your profitability. Okay, so you have all these kind of costs, and trust me, it's not easy to gather all this kind of information. So once you get those costs, you also need to look at the demand volatility. Are you good at forecasting the sales or not? You need to look at the supply reliability. Can you trust your supplier or not? I have to say this is often a challenge because it's so much data to get from so many different sources and to discuss with so many people that part of the art of inventory optimization is gathering this kind of data. Once you get the data, then you can move into doing the modeling and the mathematical optimization.
Okay, so I did the hard work. I have the profitability information. I have my demand volatility, which is demand variation, average demand, supply variation, supply lead time. I've got all that. I've got my model sorted. Now, I bought your book, and I should be able to pick some tools and techniques to hopefully follow and achieve the result which you mentioned at the start, which is 30% inventory reduction while achieving the same performance level. So is this my assumption is too simplistic, or there's something in between?
So that's basically it. So you get all the data, or you get part of it, and you will have to do some assumption. And then the book, and what I propose even without using a book, that you start with more simple model, taking more assumption. And once it's worked, when you feel confident that you got it, you can move on to using something more complex and something more complex and so on, right? And this is really a journey that I propose to the reader in the book, saying, okay, we're going to start from something very simple that you could find on Wikipedia, but we're going to really understand the limit of it. And then we're going to move on to something more complex, and then something more complex, and so on. But each time we do another step, we make sure that the basics are really correct. And the more you progress into this journey, the better your inventory is. And at the end, you can achieve this kind of reduction of minus 30%.
Oh, I think that's fine. But in my experience, I've got some more simplistic tool, maybe not as sexy as you probably propose in your book. I have a simple Excel tool where basically you take all the factors you mentioned earlier, which is the demand profile, lead time, current stock, service levels, the usual curve of if you want to achieve 98% service level, is the factor is 1.98. If you do 92%, 1.65. So I've got all that, right? The issue I see is this. So once you do this inventory optimization model, the data spits out, which recommends the changes, which is, okay, for example, your X amount of item, which was made to stock before, now the model is recommending into make to order because, there's no need there. The data doesn't says that. On other hand, vice versa. That's fine. So my question is this. Actually, I have two parts of the question. The first question is, modeling is one thing, but having the real market input in terms of product management, how they want to see things, right, is also very important. For example, new product which you put in stock six months ago, we all know it never sell as we want it to sell, right? There's always a different variation in terms of how the demand will actually grow or for the new product introduction. So my question is this: modeling is one thing, but what is the next step in terms of aligning with the key stakeholders, whatever the model suggests? May it be change of the stock profiles, change of the, for example, rationalization. So how do you suggest?
Yeah. So before I answer this very important question, I want to mention something. So you said, okay, on my blog, I have this Excel file and so on that might be not as advanced as in the book. I want to say something about inventory, and I'm a strong believer in Python, and I'm advising everyone to follow Python. I have to say, for inventory, you can do some nice stuff only using Excel, at the condition that you really understand those models. Because what I've seen is that, again, in inventory, I really advise people, if you're afraid of Python, you're afraid of anything complex, that's fine. You can start with Excel, and you can do some really nice thing in Excel for inventory optimization, at the condition that you really understand the model you're using and the input parameter. I think it's much better to do something simple in Excel, but with the right parameter, than something very complex in Python with some, if you misunderstood anything, right? So I advise people go and try those kind of Excel files, but just try to really master them. Coming back to your issue, is that basically what you're saying is that, Nicolas, your model will not work in 100% of cases. Muddassir, you're absolutely right. those models will never work in 100% of cases. You have new product, you have data items, you might have a supplier who is out of stock. Maybe you got a new supplier that's a challenger that tells you if you buy from me, I will give you a 10% discount, all these kind of stuff. An inventory model, it's going to be nearly impossible, if not totally impossible, for the model to know what to do in all those kind of situations. What I like to say is that those models support planners. So it's a tool to help you out. And it's a tool that in 80, 90, 95% of cases is right. But you still have 20% of cases that the tool is saying like, well, I do not know. That's one of the things I'm trying to do now as a consultant, because beyond my writing, the time I spend writing and teaching, I'm also a consultant. I'm trying now to do models that say to the user, should you trust the model? So the model itself is saying, well, for this item, maybe you should not trust me because it's a new item, because it's an old item, because the supplier just changed. So as the planner, instead of just looking at the math in the model, you just take your phone and call the supplier to know what is going on, right?
Very good, very good. No, I get that part. So now we move to the third part of the, which I'm actually interested, which is I'm trying to learn myself, but not really sure where to start. And maybe you can guide me, people like me, which is definitely the Python, which is the basics of the machine learning. So what is the journey in step? Because I saw one of your very interesting posts on LinkedIn, where you almost framed out a step-by-step, let's call it guide, the way you start with Python and how you end up with the, let's call it, not advanced user of machine learning, but good enough user of machine learning to start using in your supply chain modeling.
Yeah. So Muddassir, first, for all the people listening to us, I want to state again that I'm really strongly advising anyone in supply chain today that wants to do forecasting, inventory, or anything that requires data to move on to Python. Python is not difficult at all. It's really easy. It will really enable you to achieve things that are impossible to do in Excel. So it's really important. How do you do that? Well, my advice is to pick up a class online or to see a site that gives you some basic advice, or a book, I do not know. You have plenty of resources, YouTube videos that teach you how to use Python for data, and the library that is used within Python is called pandas. So what you really need is to find a class about pandas and not so much about Python. I mean, if you get a class that teaches you how to...
Class about what?
Pandas.
Pandas.
Okay. Like the animal, okay, with the S at the end, pandas. So if you follow a Python class today that would teach you how to solve Sudoku, that will be of no help in supply chain, right? What you need is pandas, and that will help you out to basically do data manipulation in Python. So you start this class. After a few days, few weeks, you start to feel like you can extract an Excel file, deal with data, and export the result back in an Excel file. As soon as you feel this, so I'm not saying you need to master it. I'm just saying as soon as you feel like, okay, I feel comfortable with this thing, I would really advise you and advise anyone listening to us that as soon as you need to do something in an Excel file at work, something repetitive that you do like every week, every month for a big exercise, try to do it in Python. First time you're going to lose time, it's going to take time, you will need to ask for help online and so on, but just try step by step to replace anything you're doing in Excel by Python. Step by step, you will feel more and more confident into it. As soon as you feel like, okay, I start to get some idea, I'm advising you that you should take then another class that will be called something like Python with machine learning, or machine learning with Python, data science with Python, anything like that, right? And then you can start to work with machine learning. Again, it's not really difficult to work with machine learning, but you need to get some basic of Python. Again, I am not saying you need to be a PhD in Python before you move on to data science. You don't need to master everything out of it. But, you know, just get the basic, how to use an Excel file, manipulate a bit the data, move on to machine learning. Again, as soon as you get the basic of it, I really advise you, take a try with supply chain. Try to predict something. Try to predict the sales. I wrote a whole book about it. It will show you how to do that in an easy way. You can also predict many other things, like, is this machine going to break up tomorrow? Try to get a data set and predict anything and play with machine learning. And you see that as soon as you do a first thing, you will learn things and you will be able to do something bigger and bigger.
So a slightly stupid question. I can do all that you said in Excel as well, if I'm an advanced Excel user. So where technically Python or the second step of the Python, as you said, machine learning using Python, it gives better results or better advantage. So maybe you want to give an example for that.
Yeah. So personally, I would only use Excel today if I have a table with 20, 30 lines max, and I want to do a bit of, coloration, put the cell in yellow or orange, those kind of things. If I have anything bigger than that, I'm moving to Python. If you have to deal with multiple Excel files, you have, I don't know, client information in one file, the master data in another file about your product, and then the demand in another file. As soon as you have this, as soon as you have to do a VLOOKUP, I strongly advise you move to Python. Again, you will be able to do it in Excel. I'm not saying you cannot do it in Excel, but it will be easier to do it in Python, and moreover, you will automate it. So next month, when you will need to do it again, it will be basically for free. You press a button, you get the same result, right? And this is what you want to do. You want to save yourself time, so next time you do it, it's for free.
Perfect. And I also see, because I have a little application on there's a tool called ABC Analysis. There's a little, actually just one line of Python formula written behind it, where you just upload your last term of sales and it will give you ABC analysis in like 60 seconds or even less. So absolutely, Nicola is absolutely right. The amount of time is saved. And if you don't believe me, just go to the tools in my blog, click on ABC tool, upload your data, and you'll get whatever you do in 2 weeks, you can get in 60 seconds. So totally support what Nicola is saying. But I am actually very interested on the web application. So once you master all this, you can create, my understanding is, super nice web applications which people can use, correct?
Totally. This is something that's also possible you can also do it in Python. I'm not an expert myself, so I will not be able to tell you how, but for sure, once you master Python, you can also build some kind of nice visualization tool if you want to. What I personally do, again, it's just my personal taste. I like to move back the output to Excel and then do a graph in Excel if needed, or just do a graph in Python and save it as a PDF. Again, it's a new tool. It will help people to be extremely fast and to scale all the data analysis. And this is really, I want to say to the people in supply chain, if you want to make your life easy, move to Python.
No, great. But let's say, what about the other tools like Power BI and things like that? I mean, that's also out there, right? For people to learn if they want to learn.
Yeah, sure. I'm not personally a user of Power BI, so I will not be able to tell you what's the limit and so on. So for sure, you have plenty of tools. And for example, you could also say, okay, Nicolas, but I could do VBA in Excel. I can do macro to speed up my work. For sure, you can do that as well. Again, I think that Python is easier to learn than VBA. So if today you're thinking, maybe I should do VBA, maybe Python, I really can tell you Python is easier than VBA and will bring you much further. Another thing that's very important to understand is that you will not be able to do machine learning in VBA. You will not be able to do machine learning in Power BI. You need to use Python or any other language like R and so on, right? So if you want to go for machine learning, then there is no choice. It's Python, R, or you could use some software as well, like, for example, SAS and so on.
I mean, maybe we can do a separate episode on machine learning because that's a very interesting topic. But just maybe a precursor of our next conversation of how machine learning can bring real innovation in what we do in supply chain.
I'm going to say it like that. If today you're a supply chain analyst, you like data and you want to deal with forecasting. And forecasting is a very easy project to sell inside. If you go to management and say, okay, I have a way to make our prediction more correct, everyone will say, okay, that's great, of course. If you want to do better prediction, you have two ways to do that. Either you go for statistical model or you go for machine learning model. Using machine learning model will give you an edge to statistical model most of the time. That we see that year after year, machine learning are better and better, and statistical model basically stay where they are. And what I'm going to say is very important. Machine learning is easier to implement, to tweak, and to implement them than statistical model. If you want to implement statistical model yourself on Python, I know it because that's also what I do as a consultant. It would be maybe 500 lines of code. If you want to do machine learning, I've noted down that in the new edition of my book that will be out soon, you can run a neural network, including data cleaning and the output and the forecast, all of it in 65 lines of code in Python. So in 65 lines of code in Python, you get a neural network to do the sales forecast for your company. And this is it, okay? So it really means that it's not so complex. And if you want to achieve those kind of things, if you as an employee, you think, okay, I want to grow in my job, I want to do something really cool, well, why not doing neural networks? You can do it. It's not that complex.
Perfect, guys. I mean, this is perfect, right? So this is could be a good precursor for our next episode, because I think the conversation already is too heavy for the faint-hearted. But I absolutely learned a lot. Starting from how you said the first step is to collect the data, which gets your basics right, gets your assumption right, create your own set of data, start doing the modeling. You could do in Excel, but as Nicolas said, you need to know your Excel, you need to know the formula so you can understand the output. The second thing we discussed with Nicola today is Python, how Python can make life easier and save time. And as a supply chain people, this is what we want for repetitive tasks, which mostly we have a repetitive task because the business model is not changing with some variation. So start learning and then move to start learning Panda, and then next step would be machine learning. But let's do things step by step rather than running too fast, right? So I would just like to say thank you, Nikolai. It's been a pleasure talking to you. What I'm going to do is I'm going to give the links of Nikolai books into the description. So if you're looking for the books for Nikolai, please click on the link, or I will tag him on the link anyway. You can contact him. He's a brilliant guy. He's doing the very awesome stuff. So thank you very much, Nikolai. Any final comments?
Muddassir, the final comment is that it was such a pleasure discussing with you. I think it's very interesting for all the people listening, and it was a pleasure. So I'm looking forward to the next time.
Thank you very much. Thank you very much. Cheers, right?
So if you like this video, don't forget to like, share, subscribe, and leave your comments below.